speaker. Our keynote speaker, I'm very happy first that she accepted the invitation. She's a friend of KidneyCAN. She's a friend of many of us, but she's a major force, not just in oncology in the US, but also in American medicine in general the past decade. Currently, as of May 2025, she is the CEO of the James and the Ohio State Cancer Center, and I'm happy too because I'm a Buckeyes and I don't like Michigan. And before that, she was the chair of medicine at Vanderbilt, and before that, the hem-onc chair at UNC. But between being the chair of medicine at Vanderbilt and becoming the CEO at Ohio State, she took a very small, insignificant job and became the NCI director. So, and I really hope, because we do miss her a lot, that she's not the last NCI director. And in only 2 years, I believe, or a bit less, she's done an extremely amazing jobs and shake things up. We had her many times at ASCO, and hopefully, again, you're not the last one. Multiple awards. One of the last one is the National Academy of Medicine. Lucky for all of us, Dr. Kim Rathmell started her career by being a kidney cancer biologist. She's a medical oncologist, a physician science by training, and she contributed heavily to understanding the genetics and epigenomics of kidney cancer and was instrumental, her and another winner of our awards, Dr. Marston Linehan, very involved in TCGA. I believe that kidney cancer is one of the few tumors where there was 3 TCGAs for. Most important to me and many of us, she's truly a mentor, and above a mentor, a coach, and she remains, I don't know how she do it, very humble. You only have to go to her social media profile, and she has more than one. The NIH one is still active, but the personal one. And she says on her profile, she remains a student of kidney cancer. Kim, welcome. Thank you. I'm gonna go.
Okay. Yeah. I'm well over 50, so I can't hop up there. So thank you for the kind introduction. It's a real honor to be here. It's really nice to be back in a place that I know and with friends, and I'm really excited about the topic that I was given to talk about. So we just had a great talk from Brian about the state of affairs and the need to address the issues that are really facing us as a field. And in particular, as you heard, one of my big passions is around early career investigator development. And so that's the topic I was given. So let's see if I can move forward. There we go. So I'm going to get away from the podium. Thank you for putting it in the middle. So the topic I was given was leading the way in fostering early careers with a focus on kidney cancer. And that is what we're going to talk about. But as I've been making some transitions, as you heard about, I've been thinking a little bit more about our science, which has really gotten into metabolism more lately. And a topic and a title I've been using for my science has been metabolizing and adapting in a complex cancer environment. And by the way, that's a good title for what we're going to talk about here today too. Like, we have to metabolize what's happening, and we have to adapt, and we have to think about it in a way that is very complex, and we think about really moving forward. So with that, here we go. So first of all, in terms of conflict of interest, I went to the government, so I personally don't have any, and they strip you of all of them, but my husband was doing some stuff before, so that's all old. But I think disclosing our conflicts of interest is really important, but it's also important that we talk about other things that are part of our conflict portfolio. And so one thing that I like to try to do is make it clear, like, where do I spend my time outside of work? What are the things that really drive me? And when you look at those list of conflicts, for me, it's a lot of foundations that are around creating innovation in cancer, around early career development, young physician scientist development, and creates a good portfolio. So I encourage you to do it for yourself and to talk about these things, because it's important that we use our time, talents, effort, and skills in the places that really matter. So, okay, I'll set it up with just a word about the state of science. So, number one, the technology is amazing. And we're going to hear so many good talks in the next day and a half on sort of this inflection point of being able to do things faster, to be more detailed, to be really in reach, and to really be able to tackle the rarest of the rare kidney tumors, to look at what's really happening in patients at different dynamic places in their cancer journey in ways that we never could before. So we can learn so much. It's really tremendous. Everything's gotten more complex because it involves lots of different team members. The expertise that's required is more than any one of us can actually bring to the table, and so we have to think about not even just our normal multidisciplinary team, but every team now probably needs to have, you know, a computer scientist who can take us into the AI realm in a more sophisticated way, as well as other ways that you know, technology and advancement is really moving fast. And building our pipeline of people, ideas, and support is a critical support to this community. So this is why talking about early career is really important. So bottom line, we need more people. We've seen this in kidney cancer. Kidney cancer, when I started some years ago, 20, 25 years ago, we wouldn't have had this size of a room. Well, you know, lots of you were here with me, but it was a smaller community, and so what we could do was not as big. And so we need more minds, more perspectives, and more inputs. And that contrasts with what seems to be the state of affairs, where everything seems to be contracting. So, you know, how do we balance that, and how do we find the right space? All right, this is a talk really for the early career investigators. So maybe I'll see who's out there. So we just heard that 50 was a critical point for parts of our anatomy. So who's under 50? We have someone, oh good, we have lots of under 50. Oh my gosh, okay, now I really feel old, okay. How about under 40? Do we have some under 40s? Oh good, okay, good, yay, I'm so glad you're here. Okay, so I thought one thing people might be interested in is like, what happens when you are like suddenly unemployed? Because most of us don't do that, but I got to do that. So what I did during that time that has set me up well for some of the future is think a lot about how we tell our stories. We really have to find a way to be engaging with very broad audiences, and Brian alluded to this. You know, when we talk to members of our community, when we talk to people who have funding decisions that they're able to make, we need to be able to share the compelling factors that are parts of our stories. We need to be engaging communities in different ways. One of the things as I kind of spent some time reflecting and talking to people and thinking about where our silos are, I realized that our medical science silo is really, really rigid with a big moat around it. And not because of, you know, everyone has some ego, but I don't think that's the driver. I think it got really complicated. It got very necessary to, you know, speak more with experts in ways so that we could all be able to develop the kinds of cool ideas that you're going to hear all about today. But we lost somewhere in there real ties into the community. Where are the opportunities to sit down with a group of community members who are just interested in cancer and talk? And a lot of those are missing, so we need to recreate those. I will tell you I did a few of those. I had an opportunity to be invited to a couple of community type events. First of all, there are not as many of those as there used to be. But I got to sit down in a skilled nursing facility and sort of assisted living, like more mobile, but older crowd of people. They're really interested in cancer, by the way. And they asked really brilliant questions. I learned a ton from talking to them. And I realized that no one was talking to them except for that moment in time when they talked to their doctors. So we need to look for these. I'll share another example. So I had to ship a bunch of things from Bethesda. And so I went to Staples to ship my stuff. And he asked why I was shipping. I told him why. And then we started talking about cancer. I was telling him about lung cancer screening and this whole story. And while he's putting all my boxes through the thing. And we had this really interesting conversation. I had to come back 2 days later with a bunch more boxes. And you know what happened? Like everyone from the store came up and they were like, that's the cancer lady. So I think that we can engage our communities in lots and lots of different ways. Those are very simple ones, but more organized as well. I think early career engagement, absolutely essential, because this is a fabulous career to be in. And kidney cancer is particularly special. And this is a time where the constrained resources mean we have to double down on creativity. Creativity in the way that we design our trials, the way as we talked about earlier this morning, creativity in the way we do our experiments, creativity in the way we engage career paths, and enabling people to speak together with one voice. So now, for 6 weeks, I've been at The Ohio State University at the James Cancer Hospital. And the reason that I landed here is I needed a job, so thank you for giving me a job. But it's a place with a venue that's big and where I can continue to talk about and move the needle on some of these issues. How we develop early career investigators, how we advance the science in ways that are really creative, how to really move this from discovery science into where we're really making the biggest difference we can for patients. The other thing about them that I really like is they have a really nice connection to the community, both a really good community outreach and engagement group that really reaches the whole state. We can talk about that later. But they have a bike ride, like many of you do, that engages the community to both fundraise for the organization and as well, throughout the year, takes scientists and doctors and brings them to community members to tell them about what that funding does, why it is important, and why having active research is important. So I found one of those venues to connect us to the community. So I encourage you all to try to find those venues. Okay, I decided to take a little detour in this talk and talk about science, because this is what we do. And because I was thinking about metabolism, and so I'm going to tell you a little, it's a vignette. It would take an hour to really tell this story well, but I wanted to kind of walk through some science that's coming out from my laboratory group, from a former postdoc. All the science that we do in these laboratories is done by young people who are developing their careers around science. So my lab for a long time has studied VHL-driven kidney cancer, which has this classic setup of Warburg type metabolism. You all know this very well because of the transcriptional effects of HIF turning on all these genes that should make our cells be very glycolytic. As you know, we've studied this in a lot of different ways, and it was a big deal, right? And was the impetus behind the Nobel Prize, including specific work that happened in kidney cancer to earn the Nobel Prize in 2019 for the recognition of hypoxia driving cancer. So, as we've been studying metabolism, we find that the story, it just gets more interesting and more complex. When we went diving into, we called it the Tumor Juice Project. That's why that picture looks like that. This is Brad Reinfeld. He was a graduate student with us at the time, looking at what's being consumed in the interstitial space. We found a surprise that, in fact, there was plenty of glucose, but there was really high levels of things like glutamine and the lactate that we kind of had expected. So the things that were in the interstitial space didn't quite fit our expectations, and so we can learn that there's all different kinds of things happening in there because, in fact, the cells are having to make some choices about what they're choosing to consume. There's all kinds of nutrients out there, and just like this kid, you have to decide, are you going for protein? Are you going for sugar? Where is it that this energy source is going to come from to drive the tumor? Along the way, actually earlier along the way, we had looked at some human tumors. We had profiled several large renal masses. We'd done some gene expression profiling using a gene expression profile called CCA, CCBA, put them into a bad, good category in terms of their overall prognosis. And then we did MRI PET scans. because that's a very direct way of saying, is that tumor metabolically active or not? And what we found was that the more metabolically active, the areas that had the highest level of PET uptake, glucose uptake in those tumors, were also the tumors that were more likely to go on and metastasize. So Emily Arner, a postdoc in the group, decided to dive in and say, why are they metastasizing? What is different about these tumors? And so she went looking for metabolic genes that would be more associated with those metastatic tumors. And what she found was there were a lot of metabolic genes that are involved in this. Metabolism shifts are a critical part of what's happening. And she found one that you can see one red dot in there at the top called NDUF-A4L2. Terrible name. They're actually in the process of renaming it, but I think the new name's not so much better. And what is this? A gene we never heard of. NDUF-A4L2 is downstream from HIF. Haha, fits our world. So it makes sense that it would be high. Why it would be higher in metastasis, we weren't really clear on. And what's putative activity is that it inhibits electron transport chain complex 1, so turning off the mitochondria. So why would that be good for metastasis? I don't really know, but it kind of fit with our model that there was more glucose uptake, like maybe you were more glycolytic in the more metastatically driven tumors. That could appear to be somewhat counterintuitive to some other studies. So at UT Southwestern, Ralph D. Burdanis' lab is doing beautiful work where they're really looking in patients, infusing carbon-13 to trace nutrients that go into the bloodstream through the tumor and land where they land to see what's the metabolic profile looking like. And what he shows, there's too much data on this screen, but sort of the graph there in the middle that's just red and black, you can see that actually in the primary tumors, there was much lower metabolic activity in terms of their mitochondrial work. That kind of makes sense with what we were seeing with NDUF-A4L2, because we were only looking in primary tumors, if it's suppressing mitochondria. But his metastasis was all high. So if you look in the metastatic tumors, they are all super happy to use their mitochondria. So that's kind of counterintuitive to what we'd seen. So we're still, I'm going to tell you, I don't have the final answer on this, but we know that whatever NDUF-A4L2 is doing in there, it is functioning as a switch to turn on and off the mitochondria. So the graphs on the right show the steady state level of the gene, which is shown in the top graph in bluish and black. So bluish is steady state. Knock out the gene, suddenly pink. They're doing lots of mitochondrial work. Turn it back on, overexpress the gene, and it goes back down. So it is functioning as a switch. So and the bottom graph shows that as well. So there is a switch that's happening. So there's really a dynamic effect inside those cells. And we showed when we knock out NDUF-A4L2, tumors that normally could metastasize normally don't anymore. Okay, so it is a factor and a driver, but what we think might be happening is at the level of the primary tumor that there are a small subset of cells that have a unique metabolic set that allows them to escape. But that there may actually be a big set of toggles before you get yourself to being a metastatic tumor. All right, that's my deviation into science. So VHL and HIF drive metabolic programs. We know that that's important. The tumor mitochondrial metabolism is tightly linked to metastatic potential, and that I didn't show you the data. We showed that those metabolic changes actually lead to further transcriptional effects by altering histone methylation. So this is all interconnected. It is all really complex science. It is all something that Emily didn't do on her own. She had to have lots of different expertise that was brought into this project, and what we learn from this will eventually help us understand how a tumor cell makes that decision to go from hanging out nicely in the primary setting and going off to be a metastasis. And you can easily see the opportunity to try to prevent metastatic spread. So that's the science for today. The reason I tell you that whole story is, one, it's always fun to talk a little bit about science. It's a big sciencey meeting, but because we can't lose that. And I'm not sure if these overlap, but these are, some of the pieces in the press, like what Brian showed, that in a very short period of time, some rapid changes have come to suggest that people may be walking away from careers in science, moving to other places where they can more effectively do their science, and that we could suffer, and we're already seeing effects of a brain drain. Before I get further, I'll say this was happening even before. We were already seeing some brain drain, but now, like, we've just opened up the drain, and it's moving really fast. So this is the real talk. For all of you who raised your hand who are under 40, so the point is, number one, that we urgently need young minds in this career area. We need those perspectives in science, and the bulk of the rest of this talk is exactly for you. And the points will be that the science demand and opportunity is really tremendous. We're really at a unique point in time to meet this moment and see changes in the way that cancer is cared for, the way it's prevented, the way it's detected, the way we manage it holistically than we've ever been able to see before. 20 years ago, it was commonplace for a discovery, for you to expect that might take 10 years or 20 years for something to really happen. That's not true anymore. It's already compressed, and we're at a place where we can compress that timeline even further. And that's the expectation of the people out in the community. Realistic or not, they're seeing that the rest of society is changing and moving really, really quickly, and medicine needs to keep up with that. It means that we have to solve challenges, but that funding challenges are part of this problem, but it's only a part of it. We have to apply real creativity, and I think the critical point is that this situation really demands that we empower our early career scientists. So that's going to be the point. So it's all about metabolism. So all my imagery is about food, so that we stay in theme. So number one, never been a better time to do science, to be doing biomedical science. I already have articulated that. The technology, the kinds of questions we can ask, the ways that we can make critical advances much more quickly. Never been like this before. This is also the time to really be bold. So to the young people in the audience, I really encourage you to think about, where you are and the ability to just invite the challenge. The narrative that I'm trying to move away from, because I do think we need to foster young people in our field, is we need to protect the young, which to me sounds like wrap you up in bubble wrap and hope that everything is better sometime in the future and then let you go. That's not going to be the way we make this go forward, right? The way this go forward is that we protect young people by having their back, right? That we put them out front. And here I'm talking about postdocs, early career investigators, people who are in the field, developing our very young, elementary, high school, college-age students, graduate students, and accelerate bringing them to the table, okay, so that they can bring bolder, creative ideas out there. So the pictures of cakes here are because, think about, we ask somebody, like, make a cake. Yeah, the first cake that you're going to make is a sheet cake in a rectangular pan. But when you're a scientist, right, your analogy to, like, now it's time to make a cake ought to be something that looks like maybe it's defying gravity, right? Or takes on a different kind of approach to how you even display the cake. So think about that when you're thinking about the kinds of studies that you want to do and the kinds of opportunities that you want to take on. Just invite the challenge. Okay, it really does cost money to do this work. Okay, so the funding issue is very, very real. And we think about, well, we just need more money because we need to do more science. That's true. Okay, first of all, I ran the NCI. I can tell you that we did not have enough money in the system for the work that was appropriate and needed to be done and was urgently ready to be there. Okay, so I'm not arguing that we don't need more funding. But how we manage ourselves as scientists also needs to take a look at how we approach it from a business angle. When I was running my lab as a junior investigator, I did always think of myself a little bit like a small business, but not with the same pressures of a real small business. I mean, if you have a laboratory of 5 or 6 people, think about yourself as if you're like running a coffee shop and you have 5 or 6 employees, right? If you have an employee who is really not fully engaged, who is showing up late, who is not doing the work that you're expecting from them, do you just kind of let that go? No, you don't. But I see that happen in science all the time. There's sort of an expectation that scientists just need like this extra time to breathe. They do need time to think, but we all also need to be a little bit more intentional about who is in our team. What are we expecting from people? And now I guess I'm starting to sound like a CEO as I'm saying these things out loud. But what is the makeup of our team? How can we utilize our resources in ways that are more cost efficient? If you're a small coffee shop owner, you might have to, and he actually looks like he has something better than coffee shop. But if you're a small coffee shop restaurant owner, you may have to think about ways that you partner with something that's bigger to be able to offset costs. You may have to think about different ways that you work with the resources that you have, which is time and space, as well as money and ideas and concept. So this is not always totally intuitive. And I will also say one of our flaws as a field is that we don't teach young people who are starting out how to do this effectively. We don't teach young people how to have difficult conversations. We don't teach young people how to negotiate for rates or how to balance a budget necessarily. And I'm as guilty of that as any. When I was a young investigator, my approach was to write as many grants as I could and hope that it covered the best, right? Somehow, that moved into where I am today. I did go back to business school to get to this. And I didn't do that till I was after 50. I'm not saying everyone needs to go to business school, but we need to include this in graduate education. We need to talk about this in postdoctoral training. We need to have candid conversations about the tracks that people are on if they're looking forward to careers in academia, at the intersection of patient care, in industry, or in foundations or other work. We need all of them. We need to embrace all of that, but we need to really think about it intentionally, like a business. The other message that I would say to young people that hopefully you already have learned is that it's always wisest to invest in people. So the people who are around you are the people who will really make all the difference for the team. And it's really supporting their development and engaging with them to be able to be working at their highest level, being able to have some of those more candid or difficult conversations to get them to the right place, and investing in the projects that they have so that they are also fully part of the team. I think the other part of investing in people is the conversation we're having right now with young people, is bringing everyone to the table and really listening to ideas from people in all different spaces. For young people in the audience, those are so old, we were largely here for that history. But it is really important to be a student of history. It's important to know where this whole thing came from. Like, how did we get to where we are and how we treat kidney cancer? How did we make the decisions that got us to the place where we've gone from a disease when I started, which was, there was approval for iodosil-2, which was a banned drug at my institution where I was a fellow. Okay, so that gives you no options for therapy, to today, where we're talking about, how do we choose between many very compelling different opportunities for treatment. So knowing that history as well as the history outside of kidney cancer, because we can learn from what other disease areas have learned, and maybe even outside of medicine. And I think this one is the most important, is learn to tell your stories. Every one of us has really good stories. That story doesn't have to involve, a great patient example where we made a heroic decision and they came out on the other end, whole. Those are good stories. If you have one of those, that's great. But stories can really put the personal picture on what it is that we do. I put on here a book and a movie. People tell their stories in all different ways. I really would encourage you to think about outside of social media. Okay? Social media feels like we're talking to the world. It's not. You're talking to these people. Okay? So think about where you can tell your stories and think about stories that are worth telling. So when I talk about stories, I'm just going to give you an example. I told this to somebody last night, actually. But one story that I often tell is about when I was working as a VHL hereditary clinic physician. You get whole families who come to you. And I saw a family, a mom, 2 daughters. They came to me when they were about 18, 19 years old. And for many years, we were really making good progress in understanding the cadence of the disease, knowing how long you could watch a renal mass before you needed to intervene. Same thing for how you were going to manage tumors in the brain, tumors in the retina, et cetera. Right? So we learned how to coordinate that, we learned how to anticipate, and we had structured ways of managing patients year over year to prevent the worst of the worst. So bad side effects from their tumors or metastasis, particularly from kidney cancer. And so then the biology, as you all know, and I'm sure there will be some other talks coming up later, taught us that HIF2 is a major driver in this cancer. This is a unique subset of patients, and eventually that there was actually a drug that could inhibit HIF2. And where was the right place to do it? The community advocated that it should not just be in late-stage metastatic disease where we test everything else for the first time, but that it should be where we know what the mutation is. And so we were fortunate to have that study. So back to my family. We'd been managing this all along. And those girls, as they got to be sort of 21, 25, they were very, I'm not sure what word I'm looking for, but unenthusiastic about their future, although they knew we were managing things well. They were very clear that they were not going to have children. And they were attentive to our strategy. So when the drug came as a clinical trial, we talked about it. They were scared and not that interested. But mom went on. She was doing okay. A month in, we don't know if it's working, but she was tolerating it all right. So then daughter 1 went on, daughter 2 went on. I don't have to tell you the rest of the story because they're one of the 40-some patients who were on those graphs that showed that it slowed the growth of their tumors and made them eventually start to regress. And game-changing. We all know the story, right? But both of those young women eventually went off drug, okay? And they went off drug because they got married, because they want to have kids, and you can't have kids on the drug. And they knew confidently what to expect about how they would go back on surveillance. So we have done an enormous service to patients with VHL syndrome and set a picture for what a future can be like for many, many other kinds of cancer. So, that story to me, every time I think about those conversations with those girls, makes me realize, we gave them their life back, a normal life that they could control. And that's the kind of story that we can share. I also shared with you a story about metabolism and mitochondria, and deep down in what is the mitochondria doing? Those stories are fascinating as well. And so being able to share those stories, even in communities, is super important. Okay. Telling the stories, you have to have the stories. You have to I actually practice my stories usually, so encourage young folks to think that that's not a crazy thing to do. It's actually good. But seeking engagement with your community. I already told you that we have this Pelotonia bicycle event that puts people out into the community. So if you can find someone who will put you out there, that's the best. But there are lots of ways to be out and engaged in our community. I know it's one more thing, but I 100% guarantee that you will get more back than what it takes from you to go whatever on a Saturday afternoon for an hour and talk to some people, to go on an evening event to some people in your house of worship, to talk to some people in your local community. It will really it will give you some refreshing insight. It will also allow you to learn to tell your stories in ways that are accessible to the general public, and it builds the trust that I think is the underpinning of what has led to our fractured funding environment. And I say this especially for young people because I think this is on all of us, by the way, so everybody needs to be out there telling our stories, but I think that young people can particularly engage with their stories in a way that is even more compelling. So, all right, it's not all on them. Everybody who is over 50. Me? Just me? Okay. All right, yeah. So, yeah, don't play soccer. Yeah. Yeah. So, you know, what's on us, okay? If we're telling young people, like, rise to the challenge, bring your ingenuity, like, step up to the table, it is on us, to be honest, to challenge young people as equals. You know, to be there, not as, like, top down, but as a parallel space. We need to lean into the role of the historian and as storytellers, because we have a lot of stories, and we can share those stories. I will also say, if you feel like you have no stories, just borrow a story from someone else. It works totally fine, just as well. It is really up to us to create space. So as we're looking at this attrition of young people, part of it is because there's a lack of funding, but part of it is because there's a sense that there's no space. That there might not be space for the grants, there might not be space on the podiums, there might not be space literally in laboratory rooms in our institutions. And so both figuratively and literally, we need to make space. We need to be intentional about bringing people who are starting their careers into and onto our grants, maybe even letting them be the PI when that makes sense so that we can be the co-I. Particularly with papers. I really encourage people, a lot of us in the over 50 category have had as many papers as we really need to make our careers be successful. And so it's a transition, but we really need to work on our space being in the middle so that other people can be the first and last author on these papers. I think we also need to think about where we fit in our career trajectory so that we can move into spaces that are different so that we allow our young people to really populate our science more. And we need to reward innovation. And then the one thing I think that I've heard over and over again when I've talked to some young people about, like, what could really make a difference for you? You know, they all want, like, more money. Yeah, I know that. I'm working on that. But the second thing that I hear is flexibility. And it's those of us who are in the upper echelons who have the ability to offer flexibility. So things can get done sometimes even with less money, if we offer flexibility. Flexibility in terms of some of the rules that we have at our institutions. I'm working on that. I've only been there 6 weeks for the Ohio State people in the audience. But in how we get things done, where it gets done, what are our expectations in terms of some of our timing, and really thinking about how to adopt a more flexible mindset. And then institutions, now it's really the CEO plays a role. You know, I think this is on institutions as well, to rethink the way that we make these environments, to listen, to adapt and value early career investigators in a really meaningful way, to create those opportunities, to let young investigators really thrive, giving them opportunities to be at some of the decision-making places, at the table where we're really thinking about some major change that we're going to make for the organization. We can really value from those inputs, not just as observers, but as people who bring ideas forward. I already said flexibility, so mentors can offer flexibility, but institutions can offer flexibility as well. And I think it's most important for the institution to be cognizant of really developing strong mentors. Mentorship is absolutely essential. And mentors who understand all of the concepts of what mentorship is, that it's not osmosis, it's actually looking very intentionally at what a mentee's portfolio is, where they need to be sponsored, how we get them into the whatever committees, the relevant places in their professional societies so that they can become real thought leaders early. So we really need to think about how we develop mentors who also then think about the personal aspects of how someone gets through this career. This is a joy of a career, and it will be more so when a mentor is helping to foster the interconnection of the personal life that also fits in with everything that we do every day. So this is my last slide, I think. The kidney cancer community. So I have always bragged about the kidney cancer community. Even as the NCI director, where I represented all the cancers, and I still do as the CEO, I think the kidney cancer community has grown in a way that really sets it up very well to metabolize the situation and flip a narrative. We've always engaged young people. I'm so impressed there's like way more young people than older people in this audience. But to find ways to help our young scientists think like a business, really drive innovation, accept the challenges that are up in front of them, and to know and be able to tell their stories. And for the senior scientists to know and share that history, create opportunity and space, invite young people into the challenge, to reward innovation and allow flexibility, and for the institutions to listen and let younger scientists up to the table and to develop our mentors fully. So I think together we can flip the narrative. It's not simple as protect the young. It's really developing, challenging, engaging, and bringing everyone along. So this is my last slide. This is the young people who've made up my laboratory over the last 20-some years. And so just want to, and Jeff's lab, who we've collaborated with extensively as well. So couldn't have done any of the stuff that I have done in the scientific space without them. So with that, thank you very much. I don't know if we have maybe time for just a couple of questions.
Yeah.
I ran a little bit long. Yep.
Kim, it's a great talk. So I want to tell my story. Obviously, when I started my lab at UNC 2013, I was sharing this lab space with Kim. She actually served as a mentor for me to actually help me dedicate some of my research to kidney cancer. I appreciate that. But back to science, ND4L2, you say it's a HIF one of the targets that is overexpressed in metastatic kidney cancer. So you know the HIF2 alpha is constituted overexpressed. Do you think that between the primary versus metastasis, there's a transition that actually HIF1 alpha take over, therefore driving ND4L2, and therefore metastasis?
Yeah, so sorry, I went over it really fast. So one thing in there, we're only looking in primary tumors, so it's very, very high in primary tumors. I actually don't know what it looks like in metastasis because I don't have a good enough data set to look for it there. But even there, it's heterogeneous. It's higher in the ones who are going to metastasize. So there are all these other factors that influence how much HIF is driving its target repertoire, and I think that's something that we really need to understand. Yeah, which actually your stuff lends itself really well to.
Kim? Hey, how's it going? Monty here. That was a terrific talk. I last year took on a role at my institution, City of Hope, as Vice Chair of Academic Affairs. And a part of that role is really trying to create programs that sort of foster mentorship at my institution. But one of the big challenges I'm facing is how to quantify and appropriately reward that mentorship. Any thoughts on building metrics for really assessing the performance of mentors? Yeah,
that's an excellent question, and one I grappled with a lot when I was a chair of medicine. So first thing, I'm glad you're doing it because one of the things that I discovered is that the physician scientists kind of expect and understand what they're looking for in a mentor. They want a mentoring committee, and they're going to meet with them every 6 months and the whole thing. Clinicians have never had that, right? You move from rotation to rotation, then you get a job, and then you do a thing. And like the thought of like some committee, 3 or 4 people are going to sit down and talk about you with you every 6 months or a year, like that's a little bit foreign. So it's really great to develop those kind of mentors. I think how you reward the mentorship activity is, or recognize and support it is a challenge. When I was at Vanderbilt, we came up with sort of a list of criteria, and we were able to kind of carve out if you're doing this much and you're getting rated by your mentees as being an effective mentor, then we could, work on a piece of salary. Was one way that we did it. It gets really hard because some people are like amazing mentors, and it appears like they're mentoring like 100 people. You can't give them 100x because somehow they manage to do it in the same time that someone's really excellently mentoring 2 people. So it is hard to find the right balance. But I do think it has to be a part of the academic expectation and something that we do have to try to support, because it doesn't fit in clinical time. It comes in other time. Yeah.
Hi, Kim. Can you hear me?
Yeah.
I'm Lily Wu from UCLA, so from the West Coast side. I didn't mean to share sad stories, but I think there's need to be a balance. Everything you said is just clear to me what we need to work harder to mentor the young. But with budget crunch, with all of these cuts, there's an immediate reaction from the institution, who are mostly led by business people, finance people. Cut, cut, cut. The biggest thing that they cut was travel. Ban travel. This is ridiculous. Travel is not non-essential. This is an essential way for us to communicate science. So I'm trying to figure out if there's a way for us to make a uniform voice in saying we really, really need to bring out the young and so on, because it is draining the future. And to me, that's very, very sad. So in some ways, I think we need to make a louder, stronger voice in voicing that, fighting against that. So I'm sure that that's not just the big UC system, but many, many institutions are doing that.
I think many,
go ahead.
And
that's very important. So I'm just advocating for everyone to say something all across all science, biomedical science, kidney cancer, all cancer research. So I'm just brainstorming.
So my thoughts on it. So that's when I say flexibility, like that's one of the areas that is in my mind. Like because we can't just kind of hunker down and do science, right? That's not how science gets done. So I think it is important to articulate, what's important. And this is where, if we can give back to, the people working on ground level, like how can, if there's this much budget to cut, like how can we do it? Because I think top down, travel is easy because it's a line item, and it's a thing that isn't kind of baked, hardwired into some of the other pieces. So that's why it gets cut. But we can also offer some solutions in some of the other pieces so that travel can continue to occur. So I think we have to have dialogue, and it really does need to include people. I thought the kind of sad story you were going to articulate is about people who went looking on the job market and then didn't have jobs. Emily Arner, who did that work, had a job offer that was rescinded, and so she's stepped away from a career that would have been, she'll be successful in what she's doing, but is no longer going to run a laboratory. This is exactly the kind of thing that I think we have to be cognizant of to be able to allow people to follow the passions that they're headed toward.
I think we took more.
Yeah.
Again, another round